Hello everyone, this is C. Pavani, Assistant Professor from Pharmaceutical Engineering Department at B.V. Raju Institute of Technology. In today's lecture, we are going to discuss course Physical Pharmacy and the topic name is Emulsions. Coming to contents of today's video, we will discuss definition, advantages of emulsions and classification of emulsions, examples with the daily life examples included, and theories of emulsification. What is emulsion? Before going to the topic, let us discuss what is emulsion first. So, emulsion is basically, you may know this example. This like if you want to mix water in oil, obviously it's impossible because water and oil are immiscible with each other. So, we call emulsion as a biphasic system because it has two phases. One is oil phase and the other one is, this is oil phase and the other one is water phase. So, we call it as a biphasic system where one of the phase is dispersed as globules. You can see the last image in this. One of the phase is dispersed as globules in the other liquid. So, we call this as perfect emulsion compared to A, B, C, which are given in the above image. So, what is an emulsion? It's a biphasic system in which one phase is dispersed in the other phase. So, we also have other definition that it is defined as thermodynamically unstable systems consisting of two immiscible liquids. In one liquid phase is dispersed as globules in other, which are nearly same to the which I said previously. So, we have few examples like A, B, C, D. Obviously, we won't call the first one as emulsion. It is just two immiscible liquids which are separated by interphase. And if you see the image B, in this, it's a globules which are suspended in the other liquid. Globules is one liquid. For example, if you add oil in water, obviously if you stir it with a spoon or with a stirrer, the oil globules are distributed in the water. And if I leave it the system for 10 minutes, again the oil tries to separate from the water. Here you can see in the image C, the oil tries to separate from the water and we call it as unstable emulsion. So, when we have to call it as stable emulsion? When it uniformly distributes in the other phase. When one phase uniformly distributes in the other phase, we call it as a stable emulsion. And how it is possible? Because you might see oil and water, whenever you add it, it gets separated. If you leave it for 10 minutes, it gets separated. That's why we call it as unstable system. So, when we can call it as a stable system, we have to add an emulsifying agent to improve its stability. Then only we can get a perfect emulsion. Coming to the advantages of emulsions. Emulsions can mask the bitter taste of drugs. We have vitamin A as an example, and it's economical because we do not require expensive solvents to dissolve the lipids or oils. Here we use a water because we do not have to dissolve it. We can just suspend it. We can just suspend it as globule in the water. So, we just require water to disperse the other solvent. And it can improve the absorption of drugs by formulating as emulsions. And sustained release medications also we can prepare by using the emulsions. And we can use this emulsion formulations for nutritional supplements. We can use as diagnostic materials because we can load the radio opaque molecules in the emulsions. We can use it for diagnostic systems, and we can use concentrated emulsions as vanishing creams, cold creams. But there are few disadvantages as well because these emulsions are highly unstable systems. If the emulsifying agent or any pharmaceutical excipient which are added to the emulsion is not appropriate or optimum, then it gets separated as two different phases. Again, if it gets separated as two different phases, then we cannot use it further. Here in emulsions we have two phases. One is called as internal phase and the other is considered as external phase. In image, in this oil in water system, oil is considered as internal phase and water is considered as external phase. We also have other name for this. Internal phase is called as dispersed phase, and you can see here dispersed phase, and external phase is called as dispersion medium. So in every emulsion you will have two phases, one is internal phase and the other one is external phase. The one phase which is exposed outside is called as external phase, and the one liquid which is formed as globules are considered as internal phase or dispersed phase. The other one is called as dispersion medium. If you consider water in oil system, water is considered as internal phase and oil is considered as external phase. Let's classify emulsions now. Emulsions are classified based on dispersed phase and based on size of liquid droplets. Based on dispersed phase, we already discussed in the previous slide, it is classified as water in oil phase and oil in water phase. The same is reflected in this slide. We have oil in water system and water in oil system, in which oil droplets are dispersed in water, and in the second one, water in oil system, water droplets are dispersed in the oil phase. Okay. Coming to size of the liquid droplets, we have two major emulsions, that is macro emulsions and micro emulsions. Macro, obviously the name itself suggests the size of globules is little higher than compared to the micro emulsions. So in macro emulsions, the size of globule size is 0.2 to 50 mm micrometer, and in case of micro emulsions, the globule size is 0.01 to 0.2 mm. Okay, and we have one more system, that is multiple emulsions. Basically, these multiple emulsions are used for sustained action. If you want to prolong the action of the emulsion, then you can go for multiple emulsions. Let me give you one example of multiple emulsion. So the first liquid, which is called as continuous phase or external phase, and the other thing, the globules which are formed, is called as internal phase, and again inside the globules we have other globules. So let us assume this external phase as water and internal phase as oil, and inside the internal phase we have the other globules which are made of water. So we call this system as water in oil in water system. We have the same thing, we can also form the multiple emulsions of oil in water in oil system. So mostly their uses, they can sustain the release of the drug. These are some basic examples. Milk, which we see daily, mayonnaise, sunscreen lotion, butter, lotions like body lotions, face lotions, salad dressings, all these are real life examples of emulsions. We also have few pharmaceutical examples like lotions, cold creams and vanishing cream, liniments which are used for foods and all, and we have vitamin supplements, etc. Ointments, all these are considered as pharmaceutical examples of emulsions. So let's discuss theories of emulsification. We have four theories for emulsification. The first theory is surface tension theory. So this theory states that an emulsion results when substance is introduced to lower the interfacial tension between two immiscible liquids. So as I said in the first slide, if you want to make miscible, if you want to make improve the miscibility of two immiscible liquids, we need to add an emulsifying agent. The major function of this emulsifying agent is to reduce the surface tension between the two liquids. So the better emulsion results when the added substance can reduce the interfacial tension between the two liquids. So we generally add surface active agent. By knowing its HLB, you can choose the best surface active agent which can reduce the surface tension of an emulsion to stabilize the emulsion. Next, we have the second theory, that is surface adsorption theory, and here this surface adsorption theory mainly depends on cohesive forces and adhesive forces of the particles. So before going directly into the topic, I would like to discuss what is cohesive force and what is adhesive force. And cohesive force is a force which is attraction force between the like molecules or similar type of molecules. For example, in an emulsion, you can see the cohesive forces between water and water molecule and cohesive forces between oil and oil molecule. So, similar type of molecules, the attractive forces between the similar type of molecules is called as cohesive forces. What is an adhesive force? It's attraction between unlike molecules or dissimilar type of molecules. Especially in an emulsion, you can say it's an attractive force between oil and water. Okay, and if you can manage this adhesive forces between the molecules, you can reduce the surface tension and you can improve the dispersibility of the one liquid in the other liquid. So, adsorption theory states that if you add a third ingredient, that is surface tension, in this case surfactant, in this case we are adding sodium oleate, which can reduce the adhesive forces between the liquid and solvent, then it can enhance the dispersibility of one liquid in another. Coming to the third theory, it is oriented wedge theory. It's very simple. If I want to add a soap or surfactant, so this is oil and this is water. If I want to make them miscible with each other, so what I'm going to add here? I want to add a surfactant. Surfactant, soap or emulsifying agent, all are same. So if I add a surfactant, then it tries to form the oils as globules, because here you can see oil is little lesser when you compare with the water. So oil tries to form globules in water, but as you know, this is unstable. So we need to add a surfactant which can form another layer around this oil. So the second layer is surfactant, surface active agent. SAA means surface active agent. So the second layer is formed by the surfactant, which makes this emulsion as a stable emulsion. So you can see the image in this as well. So here you can see at the interface, if you add a surfactant, obviously surfactant is made up of a polar head and a non-polar tail. So when you add it to the water and oil system, head is occupied in the water and tail is occupied in the oil. So if I stir it continuously, then inside oil globules are formed and you can see head surrounded in this globule, which contains a tail inside this. Same at each globule. So surfactant covers this oil phase and make it stable for more period of time. So in oriented wedge theory, you can see emulsifier molecules are oriented at the interface of oil and water system, which is denoted by dotted lines here. So this is a surfactant indication. Dotted lines indicate a large volume is occupied by polar head due to formation of hydrated complex between water and polar head, and it shows close packing of molecules. So here you can see close packing of molecules which can fit the cover. Inside this curvature you can see the oil and outside this you can see the water. So coming to the plastic film theory, it is almost similar to the oriented wedge theory. According to this theory, an emulgent or emulsifying agent is deposited on the surface of the droplet, on the surface of individual droplet of the dispersed phase. So whatever inside the continuous phase, we call this as dispersed phase. So this emulgent will cover the dispersed phase, so it can be stable for longer period of time. We also call this film as plastic film monomolecular layer. This film prevents the merging or coalescence of the two droplets. So I would like to concise, there are four theories. One is surface tension theory, surface adsorption theory, oriented wedge theory, and interfacial film theory. The main theory of surface tension theory is it has to lower the interfacial tension between the two immiscible liquids. Coming to the oriented surface adsorption theory, here we have to lower the adhesive forces between liquid and the solvent. Coming to third theory, oriented wedge theory. According to this theory, there is monomolecular layer of emulsifying agent which surrounds the internal phase. Even the interfacial film theory states the same, that the emulgent will form a layer around the droplet so that it can prevent the coalescence. Coalescence means merging of the two droplets. That's all for today. Thank you.
Vishnu Audio Visual Center, like and share and subscribe and click bell icon.